Hi everyone, it's Mrs. Summer here to talk about lesson 609, moles to volume and back again. So goals were to convert from between moles and volume of a single substance. Remember to have out your periodic table and your conversion chart. So here's a real world stoichiometry example. Have you ever filled a deflated bike tire? If you have, you're using the relationship between quantities of gas and volume. As you pump air into the tire, the amount of moles of air inside the tire increases, which then increases the volume of air inside the tire. So if you recall that the kinetic molecular theory in ideal gas, a single equation which relates the pressure, volume, temperature, and number of moles of an ideal gas. So N is the number of moles of a substance. R is your ideal gas law constant. This one never changes. So for the lesson that we're doing today, we're going to assume standard temperature and pressure, which is pressure of 1 atm and temperature of 273 K. So volume of gas at STP. According to kinetic molecular theory, all gases have the same average kinetic energy at a given temperature. Also, 1 mole of a gas has the same number of particles of no matter the gas. So at the same temperature and pressure, 1 mole of a gas will always have the same volume no matter the gas. So 1 mole of O2 at STP is 22.4 liters. 1 mole of CO2 at STP is 22.4 liters. So if you remember Diatomic Molecules, I never bring classwork home on Fridays, and this is also the Magnificent 7. Most of the diatomic molecules are gas at STP, so we'll work with them a lot in this lesson. So here's the conversion factor for moles to volume. 1 mole is equal to 22.4 liters, but recall, it's only at standard temperature and pressure, so 1 atm, 273 K. So 22.4 liters over 1 mole, or 1 mole over 22.4 liters. So on the map, we are going from moles to volume. So let's try one. How many liters of gas are in a balloon filled with 17.5 moles of O2 gas? So I'm given 17.5 mole O2. So I want my mole of O2 on the bottom, so moles can cancel. And then I have my conversion factor of 22.4 liters O2 on the top. So my moles cancel, and my answer is 392 liters of O2. You try. How many liters of hydrogen gas are in a balloon filled with 1.75 moles of hydrogen? Okay, to start this, we are given 1.75 mole H2. So on the bottom, I need to have my 1 mole H2 and then my 22.4 liters. So here our answer is 39.2 liters H2. So let's convert from volumes to moles. So how many moles of water vapor fill a 39.25 liter balloon? So I am given, 39.25 liters of H2O. And so my 22.4 liters H2O is on my bottom of my conversion factor, and my 1 mole is on top. So my liters cancel, and I'm left with my answer would be 1.75 moles of H2. You try. Convert from moles to volume, or volumes to moles. How many moles of carbon dioxide fill a 7.45 liter balloon? Okay, to start this one, we need to put our given 7.45 liters of CO2. And on my bottom of my conversion factor is 22.4 liters CO2 because I want my liters to cancel. And on top, I'm left with 1 mole CO2. So now my liters cancel, and I'm just left with mole CO2. So, and I get, when I do that math, 7.45 divided by 22.4, I get 0.3325 moles CO2.